Okay, so we have our samples from yesterday. Yesterday we agitated the samples and then we let them set overnight. What are some things that you observe about this, the sample as it has set overnight?
Everything, most of everything other than dirt, like wood chips, rise to the top.
Okay, so we have some matter that's risen to the top, and you mentioned wood chips. All right? All of that's floating at the top is organic matter. It's things like roots and, as Ethan said, wood chips, things like that. So the soil has been separated from the organic matter, those things that aren't soil. What else do you notice? Go ahead.
There's a split at the bottom of something and something. I don't know what it is. There's
Okay, so we have a separation of the soil itself into layers. So what do you think that bottom layer might be?
I feel like that's sand.
Ken, why do you say sand?
I don't know, looks like sand.
Okay, what about sand would make it go to the bottom?
it's mostly rocks. Right?
Okay, remember it's all of soil is different size rocks or minerals. So what is it about the size that would make it go to the bottom? Is it small or is it large? Which would sink faster? A large rock or a small rock? Large rock. So the sand at the bottom, is it going to be larger or smaller than the sediment above it? It's going to be larger. Yeah. Yeah, I like the way that you think. So what would the next layer be? If sand is on bottom, sand is the largest of the three sediments, what would the next layer be? Remember, we have sand, silt, and clay. It's going to be silt. Silt is the next largest size. And so what's that small layer on top?
Clay.
That's the clay. Right? Now, what do you notice about the silt? Well, what do you notice about the colors?
Darker.
Which one's the darkest?
The silt.
The silt. And what we find is that silt is typically pretty dark because of the minerals that make up the silt. And silt, one of the most important characteristics of silt for the soil is that it retains water. Silt helps the soil to retain water so plants have the water that they need. If your soil is low on silt, then the fertility of the soil is going to be low quality. So what you need to do, and I have meter sticks up here on the counter. What I want you to do is you will measure the height of each layer in your jar. After you've measured the height, you'll calculate what percentage of each sediment type is in your soil profile. And then use the soil triangle in order to figure out what type of soil texture you have. Okay? So let's go ahead and start our measurements. After you take a measurement, enter that measurement into your lab. Okay, so which one are you measuring first?
I was probably gonna measure the clay first since it's at the top.
Okay. So how much clay do you have? There's not much.
It's about like from here to here, honestly.
Okay.
So, I'd say half an inch of clay.
Half an inch? Okay. So record that in your lab report.
Are we supposed to be in a Word document or is it just on Canvas?
It's the lab report from yesterday. Go ahead and measure the silt next.
That's the next one right here, right?
Silt would be the middle one.
Okay. I don't know, maybe like it seems like it's barely like 0.2. Hold on.
It's 2.4 centimeters.
Yeah. Or maybe 0.1.
Okay. Ethan, go ahead and measure the silt, see what you get, since you measured the clay. See if what you get is any
Yeah, 'cause
different.
it's barely.
Because you know where the level is that you stopped with the clay.
I'd probably say half an inch and then the sand would
Another
be
half
in it.
inch?
Yeah, and then the sand, or I don't know.
Okay.
They're both the same.
Okay, so go ahead and do another half inch. And what'd you say the sand is?
I would say the sand is 1.5.
1.5?
Yeah.
Okay, so the measurements for your soil profile are 1.5 inch sand, half an inch of silt, half an inch of clay.
And then it goes up, and there's sand.
All right, go ahead and use that to calculate your percentages, and then use the triangle
This is
to figure it out.